Hello everyone. So we have a very conceptual question from the chapter of rotation, and this is the kind of question which we can get in mains. Okay, so please look at the solution very carefully. Okay, so before that, let me just tell you what the question is about. So a force F has been applied uh, at a point, at a distance, at a height of x from the ground, and that the value of x is 8r.5, and we have a solid sphere. Okay, and yeah, and we have to find the direction of friction force that exists between the sphere and the ground. So finding the direction of friction is often something which I found very challenging. So yeah, let's see how we can do this. So for now, let us assume that the direction of friction is in the direction opposite to that of the force. Okay, I can assume that, and if the value of friction is negative, then we have to realize that the direction in which we have considered friction is wrong. All right, it will be in the opposite direction. So let's write the force equations and the torque equations. The force equation is very easy. Capital F minus small f is equal to ma. Now we are going to write the torque equation. So the force F is being applied at a distance of 3r by 5 from the center, right? And like if we okay, so we are balancing torque about the center O. So let me just write that over here. Not balancing torque, we are finding the torque equation about O. Okay, so this will be, now if you apply cross product, we know that the value of torque is r cross f, right? So if you use the various methods for finding the direction, you will find that the value of torque, or the torque because of the friction and the torque because of this force which is applied, are in the same direction. Okay, you should be mature enough to find the direction of the torque. So the equation will go something like this: F into 3r by 5, since we are measuring torque or balancing torque from the center, right? Plus F into r. This is equal to I alpha. Now the value of moment of inertia for a solid sphere about the center of mass will be 2 by 5 mr square, right? For a hollow sphere, it is 2 by 3. These are things which you should remember for mains. Okay, you cannot afford to waste time by deriving these things in the exam hall. So yeah, we have cancelled the redundant terms, and this is what it will look like. We will now have two equations, and we can now easily solve for friction and the value of force which we have. So yeah, multiplying both sides by 5, so we have 3f plus 5 small f equal to 2m. Now r alpha, this thing is, this solid sphere is undergoing pure rolling, so we know that the center of mass ACOM will be equal to r alpha. Okay, so we can write this as a, and we have our first equation, f minus f, capital F minus small f equal to ma. So let's do one thing. We need the value of small f, right? So we have to eliminate capital F. So let me just multiply the first equation with 5. I'm sorry. We will be multiplying it with 3 because we have to eliminate that, right? Or let me do one more thing. You see on the right hand side, we have got an MA, right? capital F minus small f. Let's just multiply both sides with 2. And in that case, when we negate the two equations, you can see that the right hand side will become 0. This entire thing will become 0. And therefore, we have got f plus 7 small f is equal to 0. And therefore, small f is equal to minus, did I do the right thing? Yeah, f by 7. Okay. And so it, like I had said in the beginning, the direction of friction which we had assumed was wrong. The direction of friction will be towards the right. So yeah, will be forward, and that's the correct answer for you. Thank you.